I'm going to repeat that for my video. So a right triangle has one right 90-degree angle and two acute angles. And if you remember this, I don't know if I've written this somewhere, it might be later in the section. Do you remember back to a previous class where you learned that every triangle adds up to 180 degrees? Does that sound familiar? Write it down now if you have forgotten that. It's called the triangle angle something. Every triangle angles add up to 180 degrees. So if you have one angle that's 90 degrees and two acute angles that are less than 90 degrees, what are those two acute angles going to add up to? They're going to add up to 90. So you have one 90-degree angle, but then you have two smaller angles that actually add up to 90. And we reviewed the word for that last time, which is complementary. So every right triangle has a right angle and then two complementary. So just something to keep in mind. Similar triangles. Similar triangles are the same shape at different sizes. Corresponding angles are the same, and corresponding sides are proportional, meaning they have the same ratio. I talked about this a little bit. Maybe it wasn't this class. It might be my math 30 class. I think that's where it was. Okay. The whole idea behind the trig ratio, sine, cosine, and tangent is the fact that they are ratios. So it doesn't matter what size your triangle is, the ratios stay the same. And the angles stay the same. Because in similar triangles, we still have angles that add up to 180. The angles stay the same. It's just the side lengths that change. But if you're doing ratios of side lengths, then those ratios stay the same. So sine, cosine, and tangent stay the same for those angles, regardless of the size of the triangle. So that's just something to kind of keep in mind. All right, we need to make sure we remember our vocabulary for right triangles. The longest side of our right triangle is called the hypotenuse. It's across from the biggest angle, which is 90 degrees. Adjacent leg is the side of the triangle that we call leg that's next to an angle that we refer to. The named angle is what it says here, but sometimes we call that a reference. So I'm actually going to write down those words because I like that word better. So named angle or reference angle. I'm going to use that particular vocabulary a lot. So it's the angle in reference. So if we were looking at angle A or alpha, we can call it either one here, which leg would be adjacent to alpha? Adjacent, the word adjacent means next, right? So if we're looking at angle A or alpha, which leg, A or B? B. Yeah. So side B, leg B, is next to angle alpha. So if we were talking about angle alpha, the adjacent leg would be B. Okay. The opposite side is the leg across from that angle. So again, if we're talking about alpha, the opposite side would be A. And I don't know if you noticed that those letters match. That's intentional, not something that mathematicians do. They like to match the letters that are across from each other in triangles. Your triangle doesn't have to be ABC, it doesn't have to be alpha and gamma. But if it were even other letters like PQR, then you would probably have sides with little case letters, small case, lowercase, not lowercase letters PQR across from those big angles QPR, or whatever Greek letters you might be using. So even though if we use the Greek letters, it's not a direct relationship, we're using it like that. So we have alpha, beta, gamma, and we have ABC. Right? Okay, just some kind of technical stuff. So here we get to our trigonometric ratios. You've probably heard the phrase SOHCAHTOA before. I'm going to give you a couple of ways to remember SOHCAHTOA. They're both kind of silly. I'm going to tell the story first, and then I'll just give you a mnemonic device. So the story goes that an Indian chief was walking through the forest. I hope this is still politically correct, actually, to tell the story. An Indian chief was walking through the forest and he stubbed his toe, and he didn't have an ice pack to put on his toe to make it feel better. He knows stubbing your toe hurt really badly. So instead, he soaked his toe in a cold river that was nearby from the melting runoff snow water coming down the mountain. So after this story about him and his toe soaking became public, they began to call him Chief Sokotoa. Have you heard that one before? Good. Okay, and then the other one that I like, the problem with the story is that you don't know how to spell it. And if you don't know how to spell it, then it doesn't really help. So the other one I like is just a mnemonic device, kind of like you would learn in music to learn the notes on a staff or something like that, like every good boy does fine, or all cows eat grass, or whatever. I don't know if you've heard this, but this one is humorous, so hopefully you'll remember it. Ready? Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. Okay, so why do we care about what Sokotoa means, or remembering how to spell it? Well, it stands for sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. Unfortunately, Sokotoa doesn't help us memorize the cosecant, secant, and cotangent. Mostly we just remember those because they are reciprocals of the sine, cosine, and tangent. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. Okay. I've just been kind of going from what's up here, but I'm actually going to erase this one and we'll just do it from scratch. Here's a triangle with sides labeled. We are going to find the 6 trig ratios. So now remember again, a ratio is where we compare two numbers and write it as a fraction. A ratio does not depend on the size of the triangle. It actually only depends on the angles. Which is interesting because this triangle we don't even know the angles, and that doesn't matter. We just have the sides to make our ratio. You might remember actually how to use that to find the angles, but that's not important on this problem. Okay, so we're going to start by finding the sine of lambda. Looks like what we're doing is lambda. So in our picture here, we have a theta down here and a lambda up there. So lambda is our reference angle. So always pay attention to the problem you're reading when you need to do it. So which angle is your reference angle? I usually like to circle my reference angle so I don't forget. Now before I even do any of these problems, now that I have circled my reference angle, I'm going to label the sides of my triangle so I know which side is hypotenuse, which one's opposite, which one's adjacent. I usually always start with the hypotenuse because I've discovered that it's really easy for students to mix up adjacent and hypotenuse if they're not careful. Because both the adjacent side and the hypotenuse are next to lambda. So start by finding your right angle and labeling the hypotenuse. Or just find the longest side and label it. And as soon as you know that that's the hypotenuse, you know it can't be the adjacent side, right? So now we're going to figure out what the other two sides are. So the side that's next to lambda is our adjacent side, and the side that's across from lambda is our opposite side. If the reference angle they had given us was theta instead, then the adjacent and opposite values would switch names. We're not going to worry about that in this problem because we're just doing lambda. Okay, so sine is opposite over hypotenuse. So the opposite side is 4 and the hypotenuse is 5. That means that for this particular angle, lambda, we don't know what it is, but we don't care. The ratio of those two sides is 4/5. It doesn't matter how big that triangle. Like if we had a different triangle with the same angles with different side lengths, it would still reduce down to 4/5 or 0.8. What would always be that same sine ratio. So cosine would be adjacent over hypotenuse, which is 3/5. And then tangent opposite over adjacent, which is 4/3. Okay. All right, now let's practice the three you're probably less familiar with, which is cosecant, secant, and cotangent. So cosecant is the reciprocal of sine. That means all I really honestly need to do cosecant is, I'm not as worried about the fact that it's hypotenuse over opposite as I am about the fact that it's the reciprocal of sine. So it would be 5/4. And then secant would be hypotenuse over adjacent, which would be 5/3 in this case. So these ratios are particular to the triangle you're working with, right? And then cotangent will be adjacent over opposite, which is 3/4. All right, does that make sense? All right, okay, I'm going to stop that video.